In today's note, we're going to be doing a quick review of the misuse of data, and we're going to kind of review everything that we've covered in this unit of two-variable analysis. So if I look at two graphs here, and they both represent the same thing. We're looking at the scores over years in terms of OSLT or literacy tests. And we have two different graphs. They both have the same data, but if we're looking at some of the similarities and differences, one thing that we can see between the two clearly, first of all, is one has a break in the scale, which shows a magnification, or it's magnifying certain data. So the graph on the left, while it shows a drastic increase, when we look at the other one, what it is showing us is specifically this section here. So this section here on the right in the box is magnified on the left. And we can see, because at 0 there is no break on the right, on the left there is a break. So if we're looking at these two graphs, it's the same data, it's just magnifying it to show different things. So if you wanted to think about which groups would use each graph, well, if this is coming from EQAO and they're looking at, or they want to promote the use of the literacy test, and showing how Ontario is gaining in its literacy, they might want to use the one on the left because it shows a drastic increase. If we want to show that maybe the government isn't doing a good enough job in increasing our scores, we would show something on the right where it looks only like a small increase. So this is just the same kind of concepts we've looked at before, and we can do the same thing with two variable data. So again, what we want to consider is that by changing the vertical scale on a graph, it can exacerbate a small trend or minimize a large trend. So basically it can show a small trend being greater than it is, or show that a large trend is actually smaller than it is. Another thing that can be done is that biased words, so the words that you use, can also influence the interpretation of data. And again, we've covered this before in the past. So as a review of everything that we've done in this unit, we want to look at the difference between a grade 12 mark and a first year university mark. So we want to compare the two, and here we have our table. We're comparing the two. We have our independent or grade 12 marks. They are separated by looking at yes of having a summer prep, or no or not having a summer prep. So we have our X's and we have our Y's. The yes summer prep and the no summer prep we will look at after we graph our scatter plot. So the first thing we want to do is to create a scatter plot, and then we want to perform a linear regression. So rather than using our graphing calculator, we can do this on Desmos, because again, this is a lot simpler to use and you don't have to worry about owning a graphing calculator. So when you go through and you create your scatter plot and linear regression, you should have something that looks like this. We have our X values on the one side, our Y values on the other. We've created our linear regression using the formula Y1 approximate mx1 plus b, and it's given us our values, specifically our R2 and our R, and our M value and our B value. And if we wanted to, we could go through and plot our residuals to see a residual plot. And we have our scatter plot here. So we've graphed it, we have all our values, we've performed a linear regression. We want to interpret the correlation coefficient. So if I'm looking at my values, I have my R value is equal to 0.88, and my r squared is equal to 0.77. So based on this value, I can say that it is a strong positive correlation because my r value is close to 8 or close to 1. And I can say that as grade 12 marks increase, first year marks also increase. Now, if I want to look at if the summer prep course was helpful, I would look at my r squared value. So if I'm looking at my r squared value, the 77, or if actually we round it to 78, if I look at that 0.78 for my r squared value, that means that 78% of first year marks can be explained by grade 12 marks. And that means then that 12%, sorry, not 12, 22% is due to other variables. Or randomness. So because 22% is due to other variables, you could argue that the prep course is not very helpful, or it doesn't have a high degree of helpfulness because only 78% of the first year marks are or 70% of the variation is explained by your grade 12 marks. So whether you took the prep course or not didn't have that much effect, or it only accounts for 22% of the variation. There are other factors that you have to look into that may cause this. Right, so other than the prep course, you could look at part-time jobs, especially when you're in university. You could look at homework, right, how much homework is getting done. You could look at any sports, and so on. And then for D, discuss any limitations to this model. Well, if we're looking at this model, some limitations are there's a small sample. If we're looking at prep course, we're only really looking at about 5 students or 10 students in total. So that's a small sample. And there's really not much variation in grades. So we're not seeing much change in general anyways. So again, the key thing from this note is just, again, recognizing how we can misuse data, whether it's by changing the scales or whether it's by using biased words. And just a quick review of, again, understanding what our r squared and our r value represents and how to interpret those values.